Okay, so I'm from ClearVue Technologies. We are an advanced building materials company, and our mission really is to decarbonise the built environment, and we do that by designing or building the bridge between the solar industry and the construction industry in terms of engineering and product performance. For me, I'm the Managing Director and Chief Executive of ClearVue, and prior to that I was Chief Operating Officer and in charge of the R&D and manufacturing agreements and so on. So what we do is we can make a building a solar panel, and I mean the walls, the skylights, the balustrades, the cladding, and we can make that solar disappear. So the way we deploy our product and the way we've engineered the product to be deployed means that the building can be made to generate energy, have really good thermal performance, because the easiest energy to save is the energy we don't need. So if we can improve the performance of the building's air conditioning systems by having better insulation, for example, and we can make that disappear and match the architect's vision. So with our products, you would not necessarily know that it was BIPV when you were walking past it even. Yeah. So we're a long way advanced from, often when we talk about BIPV, people are thinking about, it's a rooftop solar panel sort of stuck on a wall, and our stuff is, completely different to that. So our stuff is actually the building material. So it replaces existing building materials. So a few years ago, we started developing our version 2 product, and the big advantages of version 2 were that we can manufacture on existing glass lines. It took about 5 minutes more to make than a normal window, produced about 30 watts per square metre, and that in that window we developed some of the key underpinning technology. So the seal is a very important thing in construction, and so we developed a way of being able to run cabling through the seal, and then we've had that certified with the IGCC, which is the International Insulating Glazing Council, I think it is, which they put it in a chamber and do 5,000 cycles of 80 degrees to -40. And then we've also had that certified to EN 1279, where basically they do a similar thing, 2,500 cycles, but they weigh the desiccant. So as the desiccant attracts water, it increases in weight. And so we've passed all those certifications. And it's not good enough even for it to be airtight. It has to be gas tight, because argon, which is often used in windows to improve the U value or the insulation, is a smaller molecule than air, so we have to be able to handle that. So we've passed all those certifications, and version 2 was sort of like the building block for us to get to version 3. So in version 3 we've managed to increase the silicon density, so we can get a lot more power. So it's about 2/3 more power than the version 2. We've reduced the manufacturing time in the glass processor from 5 minutes to probably about 1 or 2 minutes. Basically, they have to cut a spacer rail, put our component in, glaze the window as normal, and then put 2 plugs in, and that's it. So it's very fast, and that enables us to reduce the cost by 50%. And so that means our payback on the version 3 glass is substantially better than it was on the version 2 glass, and that will lead, notionally, to better uptake. Most of our products, when we design them, we're not only looking for the aesthetic, and we're not looking for the necessarily the power generation even. What we're looking for is the engineering behind that enables, like for example in Hong Kong, we can make typhoon glass. We can make typhoon cladding that can stand large wind loads and stuff, because we're able to manoeuvre the thickness. So some of the challenges in BIPV we've had to overcome is most buildings you need bespoke sizes. So if you walk past a building you think, oh yeah, it's all the same size, but actually usually it isn't. And so we have to be able to make them different sizes. We have to be able to make them bespoke for the project. We have to be able to make the glass with the appropriate thicknesses. So we can, and in our product range for greenhouse glass, we make a product that's only 5mm thick. And yet if we're doing a very large, super-sized window, we can make it up to 52mm thick. So there's a big difference in the weight and how we laminate and how we get cell survivability and all that sort of stuff. It's all about how it works in with the construction industry. All of our stuff uses standard frames. We don't have to modify the frame to deploy a solar window other than putting a 5mm hole in it. I think this is what I was saying before about the bridge between the two technologies. And in our case, our stuff must be a building material first. It has to do all the engineering things, the fire, the wind load, the deflection, all the things we need it to do in a building first, and then it can generate energy and it has to be thermally effective as well. So those things are what make our products different. So I'm from ClearVue Technologies. We are an advanced building materials company, and our mission really is to decarbonise the built environment, and we do that by designing or building the bridge between the solar industry and the construction industry in terms of engineering and product performance.